So in today's video we will start from the inferential statistics. Second है the first we have discussed that is descriptive statistics. उसके बारे में पढ़ा था and today we will discuss about this. So what is inferential statistics? So basically this deal with the drawing of conclusion about a large population. Like you have 100 samples, so you just take some samples and you just observe and give the conclusion about a large population. So that is called as inferential. That means you are just drawing the conclusion about the large population on the basis of past event, or you can say you just taking some sample from the large population sample. So this provide tool to compute probability of future behavior of subject, or you can say any phenomena, anything which you are going to study or investigate. So what is the future behavior about the subject? So it calculate the probability about the phenomena or the subject. So this is called as inferential statistics. So these are the two types of inferential statistics. So there's the two procedure. The first is estimation. So by doing estimation you can calculate or compute the probability of inferences. Like estimation, there is the two type estimation. So in estimation, inferential is made about population characteristics. So in estimation process or this procedure used to calculate the population characteristics on the basis of what what is discovered about the sample. Like you just take 100 samples, so about the 100 samples what you have discovered, so on the basis of the characteristics of the sample you just calculate the estimation. So there is the two types of estimation. The first is point estimation and second is interval estimate. So what is point estimate? That means if the value of statistic is for example 45, so the point will be same, like your population mean will be same like 45. In the interval estimate you just consider the range of value, like the value of statics 45, then you consider the range of value like 42, 45, something like that. You just consider the range of values to calculate the inference. So these are the two type of estimation. Now next is hypothesis testing. So by doing hypothesis testing you just calculate the inference. So statistical process hypothesis is defined as the statement which may or may not be true about the population parameter. Like you have just considered some 100 parameter, 100 samples. So now you want to clarify or just doing the hypothesis testing to verify this the probability of rejection or the acceptance. So maybe the hypothesis will not be accepted or may be accepted. So like these the two types of hypothesis. The first is null hypothesis or second is alternative hypothesis. So by taking a very simple example, you can see here. So here is the effect of biofertilizer on the plant. These are the plant and they are the biofertilizer. So now taking this example, we will try to prove the null hypothesis as well as the alternative hypothesis. So in the null hypothesis, what we will do, we just try to we just do the application of this biofertilizer, that this biofertilizer increase the plant growth. So now we consider in null hypothesis that there is no impact of biofertilizer on the plant growth in null hypothesis. So we just try to prove that there is no relation and there is no impact or effect of the biofertilizer on the plant growth. So this is called as null hypothesis and it is denoted by the H naught. And when we talk about the alternative hypothesis, so in alternative hypothesis we just try to uh, prove that the fertilizer biofertilizer have has the impact or effect on the plant growth. That means when we use the biofertilizer the plant growth will be increased. So this is called as alternative. So this is alternative. When null hypothesis is rejected you just use the alternative hypothesis which is denoted by the H naught, HA or HA capital A. So this is both are null and the alternative hypothesis. I hope आपको समझ में आया होगा. Now we will understand the level of significance. So what is level of significance? Level of significance is denoted by the alpha, and the probability with which we will reject a null hypothesis when it is true is called as is the level of significance. Means, so by reading this line you can say this is called as type 1 error. In type 1 error what we do, we just reject the null hypothesis when it is true. So you can say that the level of significance of type 1 error is the same, or you can denote it by the alpha. So level of significance is taken to be 0.01, 0.05, 0.10, or you can say. So by converting these value in the percentage, so it become the 1%, 5%, or the 10%. Now basically what is the level of significance is the probability that maybe the hypothesis will be rejected by this value, like by 1% maybe the hypothesis will be rejected, or by 5% there is a possibility of probability that the hypothesis will be rejected by the 5% or by the 10%. So these are the standard value we generally consider. So you can see also in the book these value, and in the calculation when you calculate the any population or any parameters, so just you can see these value are always, so these are very standard value. Now take the confidence level. So what is confidence level? So this is the probability with which we just accept the null hypothesis when it is true. When the null hypothesis is true and when we did accept, so what will we do? So we just 1 minus alpha, we just do the 1 minus alpha means 1 minus level of significance. So what is confidence level? Is the confidence that you have the confidence in your null hypothesis that will be accepted by the 99%. That means you have confidence of 99%, 95%, and the 90%, that your null hypothesis that is going to be accepted, and you have the confidence of 99%. So what 1 minus means, when you 1 minus 10% means 1 minus level of significance, that you will receive the 99%. So it become the confidence level. So these are the just opposite. And why we are doing 1 minus alpha? Because here we are considering the probability. And what is the value of probability? Highest value is the 1. So the value of probability always 1, highest value. So we just minus the 1 minus alpha means level of significance, and we will get the value of the confidence level. Now you can see the picture over here. Now we will consider the 5%. For example, just we are taking the 5% example of significance level, that the possibility of rejection of a null hypothesis, that is 5%. So we just take this example. Total, this is the example of total, and total means होता है, this is the one tail and this is the second tail. So we will learn about the total in the next chapter. So now you can see here, this is the middle point 0 you can say, and this is the minus 1.64, and this is plus 1.64, this value. And when we are taking 5% significance, that means 2.5% in left side and 2.5% in the right side. So these are the range where your null hypothesis that there is the possibility of rejection, because this is the significance level. So when you take the 5% significance level, and then what remaining 95% of confidence level. So what will be a confidence level? This range 95%, there is a confidence level that your null hypothesis that is going to be accepted in this range. So the remaining range, that will be a significance level, that your null hypothesis there is a possibility of 5% that it will be rejected in this area. I hope आपको समझ में आ गया होगा. Now next, now you can see here the how to calculate the value of z. So when you try to calculate the value of z in terms of z values, so when alpha is 0.01 means 1%, then the value of the z will be minus 1.64 sigma to 1.64 sigma. So now you can see here, this is the value, this is the point is the 1.64 minus 1.64. So now you can calculate from this. So this table is not as much as important, but you should know about the confidence level and the significance level. Now the next topic, that is the one tail and the two tail test. This is very important for the exam perspective, so let's understand this. So what is one tail test? So when you using the significance level 0.05 in a the one tail test allot entire alpha in the one direction. Yes, when you are using the alpha like 0.05, you can say just 5%, then the allotment of this alpha in the only one direction, that is called as one tail test. Okay, so the whole contribution of your test statics only in the one direction. When using a one tail test, you are testing for the possibility of relation in the one direction only, completely disregarding the other direction of the relationship. So by taking the example, we can easily explain the one tail test. Let's understand. Now also here you can see this diagram. So this is the diagram of the one tail test. That means you are taking the level of significance level by 5% only in the one direction. You can take in this direction, or you can take in this direction. So when you take the uh, significance level 5%, the value that will be lie in the 0.165 in this region, that is the region of rejection. The remaining region will be the acceptance means your null hypothesis that will be accepted in this, in the whole region, and there is the probability of your rejection of your null hypothesis only in this region, that is the 5% in the one direction only. So this is called as the one tail test. So when we use this test, when the direction is important and when the sign is important, or when you have the two variables, they have they have the relation, like the mean value of mean one value, like for example 45, and mean two value is 42. So now you can see here the m1 is greater than the m2. So you have to, you know that the which one is small, which one is big. So just by taking that, you want to prove the in one direction, like in positive direction, so just you consider in the positive side, or you want to the see the value in the negative direction, you just consider in this region. So when you know the sign or the direction or the value of the mean, you just take the one tail test. And when there is no relation between the two variables, or there is the relation between two variables, then you take the two tail test. So let understand the two tail test. So if you are using a significance label 0.05, a two-tailed test allowed half of your alpha testing the statistical significance in the one direction and the half of your alpha in the other direction. That means the 0.025 in each tail in the both direction. So now you can see in this diagram the alpha, that zero point 0.5 level of significance you are taking in the both direction, half in the one direction, half in the other direction. So when using the total test, regardless of the direction of the relationship, your hypothesis, you are testing for the possibility of relation in the both directions. That means you are taking the data, you are taking the values in the both direction, and you are trying to calculate the relation between the in the both direction. Like you have the like to have, you have two variables, that there is no relation between these variables, or there is the relation between these variables, but you don't know which one is big and which one is small. So you just use the two tail test. So you just use this test, and like m1 is greater than m1 barabar m2 to mean equal. When you have two mean equal, so you just use this test, that is two tail test, because you don't have which one is the bigger or which one is smaller, so you just use the two tail test. So when you use the two tail test, the significance level will be divided into two parts, point 2.5 and the 2.5. So this is the example of total test. Now you can see here the total test the example. So in total test, you just divide the 5% in the two part, like here and the here. So the significance level what represent that the possibility of rejection of your null hypothesis. So the possibility in the 2.5% in this direction, and the 2.5% in this direction, and the remaining part will be acceptance level. So this region is the acceptance level of your null hypothesis, that is 95%. So this is called as two-tail test. So now let understand the errors in the hypothesis testing. So when do the hypothesis testing? So there is the possibility that the hypothesis that will be a reject, that will be accept or the reject. So if the researcher do any error, so there is the possibility maybe your null hypothesis that is going to be accepted, it may be rejected by the error, or when your null hypothesis that is going to be rejected, or by doing the error by the researcher, it may be accepted. So only there is possibility that there are two types of pressure. The first is type 1 error and the type 2 error. So let understand the one by one. So what is type 1 error? So this is denoted by the alpha, and type 2 error which is denoted by the beta. Here type 1 error, when the null hypothesis is true, that means the researcher did the null hypothesis that the true, still the decision is wrong, and the researcher just rejected this null hypothesis. Even this is true. If he rejected this null hypothesis, then the error that will be called as the type 1 error or the alpha. And the opposite type 2 error is the just opposite to the type 1 error, or you can say beta barabar 1 minus alpha. Alpha, what is 1? 1 is the probability, and value of the probability maximum is the 1. So you can say like that. So when null hypothesis is false, and the decision taken by the researcher or investigator, or he just accepted the null hypothesis, then this is called the type 2 error. So it is very difficult to learn, or so by taking just a simple example or doing the in the graph, we will easily understand. Like by taking this graph, for example, a researcher take the level of significance level 5%. That means 5% means this area point minus 196 to the plus 196 sigma. This region is the acceptance region. Means your null hypothesis will be accepted in this region if your value will be come under this range. Okay, only when the significance level is 5%. So when significance level 5%, then confidence level will be 95%. Means this is the 95% region. Here your value, your null hypothesis will be accepted if value come under this range. So and the remaining part that will be rejected if your value come here or the in this region, then your null hypothesis will be rejected. So now the researchers what did researchers just take the significance level 10%. When the researcher take or investigator take 10% level of significance, your confidence level become 90%. That means your acceptance region will be less, like this region only become the acceptance region. Now taking example, your value what you calculated the value like here, like this value is 0.96 and you calculate the value is like 1. So the value 1 will be lie here or the here like that. But now you are taking the significance level 10%. So what will happen, your the acceptance region will be small. This region will be become the acceptance region because your confidence level become 95%, or you can say your level of significance become 10%. You just the researcher just take this 10%. So now your value will be out of this range. When your value will be out of range, then the value will be rejected by mistake because the researcher just take the value 10% as a level of significance. So the range of acceptance will be small, or you can say just is that this region become only for the acceptance and the remaining region become for the rejection. So now your value become out of this region, and that's why this is called as the type 1 error, because here null hypothesis is true, your value 1 that is under this range, but your researcher just take the value of level of significance 10%. By this your range become very small and the value become out of this range and that will be rejected. So this called as the type 1 error when null hypothesis is the true, and still the decision taken by the researcher or the investigator and he just rejected this. So this become the type 1 error. So like the same in type 2 error, now this region is the accepted region. Now what happened, the significance level the researcher take 1%. Okay, so when the significance level become 1%, then automatically the confidence level become 99%. That means your possibility of your acceptance of your null hypothesis is 99%. That means this range become broaden, and the range become from this point to this point, like this that will be a 2.58 and that is a plus 2.58, this range. Okay, when the acceptance when the significance level 1%. So now if your value come in this region like 2, or you can say minus 2 or plus 2, something like that. So when the 5% significance level this range only, and if your value is 2, that means it is going to be rejected. Okay, now what happen, if the researchers just take the significance level 1%, then the range of acceptance will be broadened, will be here, and your value 2 come under this range. Okay, the value that is going to be rejected now that will be accepted because this range become acceptance region and the remaining will be rejection region. So now your null hypothesis that is going to be rejected, but now you just did the mistake and take the 1% as a significance level, and now your value that is going to be accepted with that is come under the acceptance region. So that is called a type 2 error. When null hypothesis is the false and you take level of significance level 1%, so due to this the acceptance region become 99%, and that's why the you just accepted this, and the decision taken as accepted is called as the type 2 error. I hope you got the point. Now just for learning, you just type 1 error when the true means rejection and the false means acceptance. It's just for the learning, like when your null hypothesis that is going to be true, so you just reject it, so it become alpha, type 1 error. And your null hypothesis that is going to that is false, still you accepted this, so it become the error 2, you can say beta. So So now let's understand the parametric and the non-parametric test. So we will discuss about these tests. So in the previous lecture, in the earlier lecture, we have discussed about the statistics. So basically, statistics. Why we are studying these tests? Because the statistics test basically used for a small part of population. When we use the statistics only on the small population, but these parameter means basically used for the large population. Like for example, you have uh, four samples, or you can say four result. You have four result. Now these result you can find out the statistics of every result, but we use the parameter only when the number of the result is more, like you have 10 or 10, 20 results. So you use the parametric or non-parametric test to find out the result, because these are the sample size is large. So we have to use these types of test. That's why we are studying the test. So the first, that is the parametric test, that make assumption about the parameters of the population distribution from which one's data are drawn. So we use this parametric test when we make just assumption about the parameters of population. Like you are taking the population, like sample is 100, you are taking 50, something like that. So you just take the make the assumption about these 100 parameter. You just find out the characteristics, that what's the validity or not validity about the population. So they assume underlying statistical distribution in the data. And what is non-parametric test? So they make no assumption about the parameter of distribution and do not depend on any distribution. So in the non-parametric test, they don't depend upon any distribution, and they can be applied even if parameter condition of validity is not meet. If the condition for the using the parametric test is not meeting, still we can use the non-parametric test. So now let understand in detail about the parameter or the non-parametric test. In the parametric test, specific assumptions are made about the population parameter. So like for example, here you have thousands of samples. Now you just take the 100 samples and make the assumption about this population. So this the assumption that can also be applied on this large population. So this is called as the specific assumption you can made about the population parameter. But in the non-parametric test, you can't make the assumption about the population parameter. And here you use the ratio or the scale interval, whereas in the non-parametric test you use nominal and the ordinal scale. And in parametric test require more information for the calculation. As I have already told about these parameter test, it require large population, so you can use the parametric test. But in the non-parametric test, that require less information for the calculation, and assume large bell shape curve of distribution. So in the parametric test, when you are using parametric test, the population, that should be a, you can say the homogeneous, or that should be a bell shape curve. So you can use the parameter. In the non-parametric test, there is no requirement or assumption to the regular bell shape curve of the distribution or data, and there is more statistical power, because the conclusion or the result of the through the parameter test, that will be very valid. So it has the more statistical values power, that is less power, and that is less robust, and that is more robust, because here you need a more less information, you can find out the conclusion. But here you need more information, more data, more samples. So that is less robust, and result can be generalized. As already told you about the, that you can generalize the large population by taking by taking a small population of the large samples, like a thousand sample. You just take 100 samples and make the assumption or make the conclusion or generalization. You just apply same characteristics on this large population, so it can be a generalized. But in the non-population, it can't be generalized, it can't be hoga. Now the what is the advantage and the disadvantage of the parametric test? So don't require data. It for using the parametric test, it not require more data, don't require the data, quick, easy to calculate them, and provide all necessary information about the population. And what is the disadvantage? They are not valid, and the size of sample is always very big, because the sample you are taking is very should be very big. So now, then you can apply the parametric test. When you study, here shall be represented through the medium itself, and you have to rank data as well as outline, and you just can't remove. So you have to basically rank the data that you are using in the parametric test. So you use different scales, just I have discussed here, like ratio and the intermediate scale, something like that. Now what is the advantage and disadvantage of the non-parametric test? So it is very easy and apply because apply on the small population also, which is based on the specific very general condition. Means you don't require very specific condition or a specific specialization for the applying this non-parametric test. You can apply on the general condition and no specific form of the distribution from which the sample is drawn. So when you are taking the sample, you are considering sample. The specification of the distribution is not as much as difficult, or you can say as specific. And what is the disadvantage of the non-parametric test? It is losing the precision because you are using very small population. So there is a possibility that the possibility of the non-parametric result, it will be a not more precision, and it is a less power because the precision is not good, and the false sense of security. So when the parameter test would be appropriate, non-parametric test have less power. So as I have discussed that the parametric test use and is the very give the very precise data, precise result. So if there is the possibility that there is chance, if the parametric test can be applied, then the non-parametric test generally don't use by the researcher. So a large sample size can be required to draw conclusion with the same degree of confidence. And for this large, because you are taking, if you want a good confidence level like 90%, more than 95%, so you require more data. So but in non-parametric test, you can also apply in a small data. So large population required for making the good conclusion about the degree of confidence. Now let's understand the different parametric test. So we use different test methods just to find out the result. As per it depend on the population, or the population and variables. So on the different population or different, if you have more variables, like you have two and more variables, so different test will be used in the parametric test. So let's understand one by one. So the first one, that is t test. So one important thing that you have to learn in t test, that what is the who developed this t test and what is the other name of the t test, because there are so many questions related to the t test which come in the examination, like who developed the t test. So the t test developed by the ws gossett, and this is also known as the student t test. That is also very important. So many times this question asked in exam, that what is the other name of the t test, so and who developed this t test. So when we use t-test, when the population, or you can say the size of the sample is less than 30, then we use the standard deviation, this t-test. And also, so for example, if you are measuring the average diameter of shaft from the certain machine, when you have the small population, that means you have a very small population for checking the diameter of the shaft from the certain machine, so they use this method. So what we will do, you just find out the mean of the different one population against the other, or you could just compare. So t-test basically used to assess whether the mean of two population, two group, or two are statistically different from each other or not. So you just use the t-test and to assess the difference between the means of two different groups. So we will take some other example for the t-test, like here you can see this is the formula of t-test, how to calculate the values of t-test. So here is the formula. When you have one variables, when you have two variables, so you just use this formula. And here's the variables name, like x bar observe mean of sample, and use the theoretical mean of the population as a standard deviation of the sample, and n is the sample size. And when in case statistical of two samples are compared, when you have the two samples or you want to compare, so you just use this formula to find out the values. And you can see here this picture. Is there any difference between the two groups? Like this is m1 and this is m2, two mean, and you want to check whether is the difference between two mean or not. So you use the t-test when the population is less than 30. Now there's the two types of the t-test. The first is paired and the second is unpaired. So paired means the both sample consist of the same subject. For example, you have two test subject, two population like A and B. It consists 100 samples, or it contains 100 sample, but you are using only this test subject, and you are using like 10 sample you just take out, and again you just take out another 10 sample. Now you calculate the mean of both sample. Now you are comparing the mean of the both sample from the same test subject. So it is called as a paired when you are using same test subject. So these types of test become the as a pair test, and when using the distinct test subject, this is called as the unpaired t test. By taking very simple example, like if you want to conduct an experiment to see how drinking energy drink increase the heart rate, so you could do it in two way. So by using the pair test, or the next there that is an unpaired test. Like in pair test, what we will do, they measure the heartbeat of 10 people before the drink. Okay, before giving the energy drink to the 10 people, we just first check out the heartbeat of the 10 people and measure the heartbeat of the same 10 people after the drink. They just take the drink, and then we will check out the heartbeat of the 10 peoples, and then we compare. So this is called as the paired sample, because the samples 10 people they are same. You are using the you are just measuring the heart rate before and the after. And in the unpaired way, uh, it would be a measure that heart rate of 10 people before drinking an energy drink, and then measure the heart rate of the other another some group of the people and who have drink energy. And then two samples consist of different test subject, because you are just taking the 10 people from the different groups, so you would be perform the unpaired test. So for the means of the both samples, I hope you got it. Here's the picture, you can easily understand. Now let understand the jet test. So jet test basically when you compare the mean of two population with the size which is equal to or the greater than 30 samples. So you just use the t test. So it is also used for testing the proportion of the same some characteristics versus the standard proportion, or you just compare the proportion of two population. Like you have two population, two sample size, you just compare. And what is the difference between the z test and t test? Only the number of the population, you can say sample size. When the sample size but equal to 30 and more than 30, you just use the t test. Like comparing the average engineering salary of man versus women. There are so many men and women working in the organization, so you just compare the salary of the average salary of the engineering salaries of men and women. So you just perform the jet test. Now for example, you are just there's the example for the jet test. Like a survey conducted, and the survey claimed that 9 out of 10 doctors recommended aspirin for their patient with the headache. So some patient have the headache, so the doctor recommended the aspirin tablet. And this claim that 9 out of 10 doctors recommend this medicine. And to test this claim, the random sample of 100 doctors is considered, and out of 100 doctors, 82 doctors indicate that they said that they recommended the aspirin out of 100 samples. So now what is the claim, accurate or not? So we just use this formula of z test and find out the value, then we compare. So here you have to use the alpha value mentioned 0.05, you can see the. So this is the 5%. Now you just put the value of these variables and find out the value, and you can easily find out that the claim of the problem is right or accurate or not. So this is the formula of the z test. You just remember this. There are so many times the same formula I have seen in the examination. So now the next test, that is the analysis of variance. You can also call it the Anova test. Basically, this test is very important because this test can be used for more than two and three variables. So that's why this is very important. And this Anova test is given by the Sir Ronald Fisher. So the ANOVA, which is used to determine whether there is any systematically or statistically significant difference between the means of three and the more variable, more than three, or you can say unrelated groups. There are so many groups which are not related. Still, you can use the ANOVA test for the find out the significant difference between the variables. So, like taking example ANOVA, by examining the potential difference in the IQ score by the country. Like you have the three country, US, Canada, and the Italy. So you just find out you want to examine the potential difference in the IQ level. So you can use the ANOVA test. So ANOVA compare basically variance of by the means of sample ratio. So that is called as F ratio. F ratio is a formula for this. So what is F ratio? F ratio basically variance between the group. Like you have three groups, so you want to find out the variance, and which is divided by the variance within the group. So this is the formula for the F ratio. And so there are the two types of ANOVA that you can use in the different. So like the first, that is the one-way ANOVA. One-way ANOVA basically use when there is only one independent variables. So we will take some examples so that it will be very easy to understand the types of ANOVA. The other, that is the two-way ANOVA, that has the two variables, independent variables. So let's understand by taking example. Like there's the marathon. In marathon, the participant use a different brand shoes. So in one way ANOVA, that we are testing the relationship between the shoe brand and the time that is taken by the participant to finish the race. So here's the one variable, one independent variable. Okay, now taking the another example for the two-way ANOVA, here the more than two variables or two variables like the shoes brand and the here also the race finish timing, and one variable is also added in the two-way, like that is the age group. So like junior, seniors, and master. So you can see here the two independent variables. So here we use the two-way ANOVA test, and we find out the relation between the different variables. नेक्स्ट दैट इज़ दी नॉन पैरामीट्रिक टेस्ट. यहाँ पर हम बात करेंगे अभी नॉन पैरामीट्रिक टेस्ट के बारे में. सो उसमें कौन कौन से टेस्ट यूज होते हैं. द फर्स्ट वन दैट इज काई स्क्वायर टेस्ट. सो काई स्क्वायर टेस्ट ऑफ इसको इंडिपेंडेंट बोलते हैं, काई स्क्वायर टेस्ट ऑफ इंडिपेंडेंस. और इसके माध्यम से डिटरमाइन किया जाता है कि जो डिफरेंट जो कैटेगोरिकल वेरिएबल्स हैं उनके बीच में क्या वो एक दूसरे पे डिपेंडेंट हैं, क्या इंडिपेंडेंट हैं और क्या संबंध है, उसको निकालने के लिए हम काई स्क्वायर टेस्ट का यूज करते हैं. और ये नॉन पैरामीट्रिक टेस्ट है, एग्जाम में पूछा जाता है कि ये किस प्रकार का टेस्ट है. एंड इस टेस्ट को आल्सो नोन एज द काई स्क्वायर टेस्ट ऑफ एसोसिएशन. क्या बेसिकली यहाँ पर जो वेरिएबल्स हैं, जो कैटेगोरिकल वेरिएबल्स हैं, उनके बीच में क्या एसोसिएशन है, क्या रिलेटेड है या इंडिपेंडेंट है. एंड टेस्ट ऑफ द गुडनेस ऑफ फिट. और ये भी एग्जाम में पूछा गया है कई बार कि गुडनेस ऑफ फिट, जो गुडनेस ऑफ फिट जो टेस्ट है कौन सा टेस्ट है. टेस्ट ऑफ होमोजेनिटी. इसका जो फॉर्मूला यहाँ पर मेंशन है इसको आप देख लीजिए. ये जो यहाँ पर वाई लिखा है ये ऑब्जर्व वैल्यू है और ये जो एक्सपेक्टेड वैल्यू है, और इसके माध्यम से इसको वैल्यू को निकाला जाता है. नेक्स्ट है मीडियन टेस्ट. सो मीडियन टेस्ट बेसिकली यूज किया जाता है कंपेयर करने के लिए दो सैंपल की मीडियंस को. उसके माध्यम से आप फाइंड आउट करते हैं बेसिकली उसकी सेंटर टेंडेंसी, कि उसकी सेंटर टेंडेंसी में क्या डिफरेंस है, उसको कंपेयर करते हैं मीडियन टेस्ट के माध्यम से. जैसे कि यू माइट वांट टू कंपेयर द मीडियन नंबर ऑफ पॉजिटिव कॉल और जो नेगेटिव कॉल होती है, नेगेटिव कमेंट होते हैं, उनके बीच में आप कंपेयर करना चाहते हैं. तो उसको निकालने के लिए आप मीडियन का यूज़ करेंगे. इसके माध्यम से आप निकाल पाएंगे कि कितने नेगेटिव कमेंट आ रहे हैं दैन दी पॉजिटिव कमेंट, या फिर उसका वाइस वर्सा भी. तो उसको निकालने के लिए आप मीडियन टेस्ट का यूज़ कर सकते हैं. नेक्स्ट है मान विटनी यू टेस्ट. यू टेस्ट भी एग्जाम में पूछा जाता है. सो इसको मैन विटनी के द्वारा ये जो यू टेस्ट है ये मोस्ट पावरफुल और मोर यूजफुल है अगर हम बात करें मीडियन टेस्ट के लिए. अगर कंपेयर करें मीडियन टेस्ट से, तो मीडियन टेस्ट से ज़्यादा यूज इस टेस्ट को यूज़ किया जाता है, दैट इज़ यू टेस्ट. बिकॉज क्यों किया जाता है इसका कारण है बिकॉज दिस इज़ वन ऑफ द मोस्ट यूजफुल अल्टरनेटिव फॉर द पैरामेट्रिक टी टेस्ट. जहाँ पर पैरामेट्रिक टी टेस्ट का अगर हम यूज़ कर रहे हैं तो उसके अलावा हम अगर कोई नॉन पैरामेट्रिक में यूज़ कर सकते हैं वो टेस्ट है, वो है यू टेस्ट. सो व्हेन द पैरामेट्रिक अजम्पशन कांट बी मीट एंड व्हेन द मेजरमेंट एंड आर एक्सप्रेस्ड इन द ऑर्डिनल स्केल वैल्यूज़. सो वहाँ पर हम यू टेस्ट यूज करेंगे बिकॉज पैरामेट्रिक टेस्ट में आपको जो पॉपुलेशन चाहिए होती है उसकी शायद ज़्यादा ज़रूरत पड़ती है. इसी वजह से पैरामेट्रिक यूज अगर यूज नहीं कर पा रहे हैं या फिर उसकी जो रिक्वायरमेंट है जो फुलफिल नहीं हो रही हैं, तब हम वहाँ पर ये जो है यू टेस्ट यूज कर लेंगे नॉन पैरामेट्रिक टेस्ट का. नाउ लेट अंडरस्टैंड दी कोरिलेशन. सो व्हाट इज कोरिलेशन. कोरिलेशन स्टैटिस्टिकली अगर बात करें, कोरिलेशन रिफर टू दी quantifiable relation between the two variables. When we want to check or we want to quantify the different two variables and find out the relation between two variables, we just use the correlation. So furthermore, it is measure of strength and direction of the relationship. So what is the relationship and what the direction and strength between the variables? We just use this correlation to find out the relationship between the variables. So the two quantity are said to be the correlated in the following, and how much the two variables are correlated, and two variables are correlated is determined by the degree of correlation. So if you want to find out the relation between the two variables, you just check the degree of correlation, and the degree of correlation basically measured through the correlation analysis. The correlation analysis also called as the correlation coefficient. That is very important. And two independent variables will never be considered as correlated, because when the variables are independent, they have no relation between them. Then we can't calculate the correlation between them, because they are the independent. So they should have some relation between the variables, then we can find out the correlation. So it vary from plus minus 1 to plus 1, that is from the perfectly negative to the perfectly positive. If there is no degree between the variables, then that is called as no correlation between them, that is called as 0 degree. And there are the four things that can be calculated or you can determine through the correlation, like whether there is a relation between variable or not, that is called as measurement, and whether the correlation is positive or negative, so you can easily determine through the correlation, and whether the degree of correlation is significant or not, and the cause and effect relationship between variables you can also determine or establish through the correlation. So these things can be determined through the correlation. Now let's understand the different types of correlation. So the type of correlation. So basically the correlation have different types based on the different the first, that is based on the direction of change. So what is the change in the variables, in which direction? So that is called as negative and the positive correlation. And when we talk about the based on number of the variables, you have multiple variables like 2, 3, 4 and multiple. So that is called as the simple correlation, multiple correlation and the partial correlation. And when we talk about based on the consistency of the ratio of change between the variables, so we just check out the consistency between the variables of their change, then that is called as linear and the non-linear correlation. So let's understand one by one. The first, that is the positive and the negative correlation. So positive correlation is the correlation between when two variables in which both variables move in the same direction. So when both variables move in the same direction, that is called as positive. For example, like weight and the height. The taller people tend to be heavier, or they have more weight, they are heavier. So that is the example of the positive correlation. And when we talk about the negative correlation, when the basically the relation between two variables in which increase in the one variables, that is associated with the decrease of the one variable. Like this one variable, that the increase in the one variable, that is the decrease in the second variables. This is the relation between the negative correlation. Like height above sea level and temperature, like when they increase the sea level height, then the temperature will be definitely decrease. So that is called a negative correlation. And third, that is the zero correlation, when basically there is no relation between the variables, like amount of tea you drink, there is no relation between this intelligence. How much your intelligence, it didn't depend upon the tea, how amount you are taking the drink. So this is called a zero correlation. Next, now you can see here the diagram, you can see graph of the positive, negative and the no correlation. This is the positive correlation and this is the negative, and this is the no correlation. Next, that is the linear and the non-linear correlation. Basically correlation is said to be linear if the ratio of change is constant. The ratio of change is constant, like you can see in this diagram. This is the y-axis, this is the x-axis. So if the change is constant like this, the value here, the value here, the value here, then you can easily make the graph that is constant. So that is called as constant. Like for example, in a factory, 100 people are working. So the output of the factory at the end of the day, that is, for example, 100 unit could be anything. Now you just doubling the amount of the people, like you are the doubling the number of the people. So the output, of course, that will be double, 200 units. So that is called as linear, or you can say when there is the constant change. And when we talk about non-linear, there is the, let me erase this. correlation is said to be non-linear if the ratio of the change is not constant. Okay, then that is called as non-linear. You can see in this picture that is very simple. You can easily understand through this example. On the y-axis and the x-axis, and there is no, you can say the change is not constant. Is it changing, like it is increasing, then it's constant, then decreasing. So there is no, basically you can say this is non-linear correlation. Now the next, simple correlation and the multiple and the partial correlation. So basically simple correlation when you have only two variables, like you can y barabar a plus x. So if you change in x, the y will change. So there's only two variables. So you can take for the study, then that is said to be the simple correlation. Multiple correlation has the more than three variables, that is studies simultaneously, then it is termed as the multiple correlation. And partially correlation, that means the basically if there are more than two variables, but only two variables are considered keeping the other variables constant, then said to be the partial correlation. And so this is all about today video, and thank you very much for today's discussion.